Welcome to this week's midweek space news roundup. So as usual, I'm just going to round up some space news articles or social media posts I've seen in the last week or so. But first, if you're on X, please follow at Space Startup Hub, and I'll post my videos there, occasionally post other things. So with that, let's get into the first article. And this is on Voyager and Max Space partnering for deep space human exploration. So let's have a look at this article and have a read. As usual, I've just highlighted some areas. So it's Business Wire, and it's Voyager and Max Space to accelerate deep space human exploration. And there's a render there of Max Space habitats on the moon. So it says Voyager and Max Space have announced a strategic partnership to advance expandable space exploration technology. This is the inflatable habitats from Max Space that have recently been announced, and they will serve as a cornerstone of a future lunar and deep space exploration efforts for habitation and storage. And we have a quote from the Voyager CEO, Dylan Taylor. "The moon is the next operational domain in a growing space economy, where sustained operations require infrastructure designed for endurance, scalability, and industrial execution. Max Space's high-volume, low-mass expandable structure technology creates a scalable approach to human operations on the lunar surface, and with commercial emphasis towards a sustained human presence and operational continuity beyond low Earth orbit." And we have a quote from the CEO of Max Space, Salim Mian, who says, "Expandable structures represent a step change in how surface infrastructure can be delivered and deployed. And the architecture should increase capability, scalability, and versatility that are essential for sustained deep space, and the goal is enabling operational lunar and Mars capabilities aligned with NASA's exploration timelines. And the partnership emphasizes early risk retirement, interoperability, and commercial scalability as guiding principles." And about Max Space, it says, "The lightweight expandable habitat launches compactly and expands 20 times once deployed in orbit or other destination, allowing a 350 cubic meter fully equipped habitat to launch on a single Falcon 9 rocket." So that is the article announcing the partnership between Voyager Technologies, which, if you're not familiar with them, they are the prime contractor for the Starlab Space commercial space station. This is from the Starlab website. So Voyager has a $217 million Space Act agreement with NASA as part of the commercial destinations free flyer program. So they're working towards the NASA CLD Phase 2 awards, and Starlab Space is well positioned for that. This is a render of the internal layout of Starlab. It's going to be 7 decks, about 380 cubic meters, with 130 payload lockers for research. It's going to be a very big commercial space station, and they've got lots of other partners: Airbus, Mitsubishi, Palantir, MDA Space. But now they're partnering with Max Space, who will have a demo inflatable habitat, which you can see here, launching in a year or two. This is not their full-size space station. This is just a tech demo to make sure they can inflate it in space. They can check out all the life support systems, make sure everything's working, and then deploy the larger inflatable habitat, which I think they will propose to NASA for a CLD award. And this will be the only inflatable commercial space station. That's fully inflatable. You do have orbital reef that's a mixture of metallic modules and a life habitat module from Sierra Space. Internally, inside the Max Space habitat, you can see it's quite spacious, plenty of room for equipment. Here's a render of their station around the moon in lunar orbit. We also have it in Mars orbit as well. But for this particular partnership, what's most relevant is we have this render, put myself in the corner, we have this render of their habitats on the lunar surface. So at the bottom you have the metal area with an airlock, and on top you have the inflatable area. We have a larger render so you can see the layout with solar panels on the top. But you can see there's plenty of windows in the inflatable area, and that's because of the way it's constructed with cords. You can actually see the cords slightly. That's where all the tension is. So between the cords, you have the fabric, but that's not under tensions, that's not under load. You could cut areas from that fabric to make windows. That is their concept for lunar habitats. And Max Space is now partnering with Voyager technologies for concepts for lunar habitats and deep space habitats as well. That's very interesting. So we'll see how that partnership goes and see what tech demos they come up with in the future. So let's move on to our second story this week. Okay, our second story is on Rocket Factory Augsburg, or RFA, and let's bring up the post. Put myself in the corner here. So I've not really talked about them much recently because there's not been a lot of updates, but we have this X post from them recently. I think it's just the other day. So it says, technical update. The past few weeks and months have been very busy at RFA. Everything is being prepared for the next first stage hot fire, and great progress has been made on our launch pad at SaxaVord Space. So SaxaVord Spaceport is in the UK, it's in the Shetlands, in the very north of the UK. It's very rugged, barren place, but it's a great place to launch for polar orbits or sun-synchronous orbits. Let's take a closer look. Most visible and impressive, the umbilical tower is up, 52 meters high from the ground, fully equipped with clamps to stabilize and fuel our RFA ONE. RFA ONE is their orbital rocket. The rest of the launch pad has also been completed. Only the water tanks for the water deluge system will be added. We have begun commissioning the launch pad for the first test flight and expect to conduct some important tests on the pad in the coming weeks. The Launch Control Center is complete and fully equipped. It consists of the Mission Control Center and the Range Control Center. From here, about 5 kilometers from the launch site, the team will conduct and monitor the launch. SaxaVord Spaceport has completed its IAT hangar, and we were welcome to move in. This is a multifunctional hall for assembly, integration and testing that we will use for the final work and integration of the rocket stages. This is also a clean room for our customers, which provides them with optimal conditions on site and access to their payloads for as long as possible. In short, everything is more ready than ever to receive a new first stage. So that's great news. So let's dive into a bit more about RFA. So first of all, we have this render, put myself in the corner, this graphic of what the launch site will look like. So at the front here, you can see the launch tower and the launch pad, or the launch stool, as it's called. Further back, you can see the fuel farm, lightning protection, umbilical tower, flame deflector. So there was a first stage test at the end of 2024 that went wrong. It ended up destroying all 9 engines, the vehicle, and damaged the launch pad. And the reason was there was a problem with one of the engines and it blew up, but the fire suppression system wasn't powerful enough to put out the fire. So it did activate, it wasn't scaled enough to put out the flames. So hopefully they've now fixed that. They've made a much more powerful fire suppression system that can handle explosion on the pad. So let's have a look at some of the engines. These are, I think there's 9 if you count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 engines, base of the first stage of the rockets, the RFA ONE. We have a render of what it will look like when it lifts off. And this is SaxaVord. So you can see on the left of the island, the west of the island, there's a launch pad. And then to the east, further to the right, you can see some kind of building. And we have some photos just released a few days ago. So there's a launch pad and the tower, and then you can see it further away. And you get an idea just how barren and remote the place is. Then we have maybe this is the IAT building. They talk about the assembly, integration and testing facility, which I think will be for multiple companies. I think this is owned by SaxaVord, and they constructed their mission control center, apparently 5 kilometers away from the launch pad. So this is where they will monitor the launch from. And also they mentioned a range control center as well. So we do actually have a video. This is not a recent one, but it gives you an idea. So the rocket comes in on a ferry. This will be in the Hebrides or Shetland Islands. And then the ferry takes it over to the island. And then it goes on a truck to the launch pad. And then there's a crane that will lift it up onto the launch pad. This is in 2024, I believe. And this is just the first stage. But they did some testing in 2024 that resulted in the destruction of the first stage and all the engines. But it looks like they're ready to begin hot fire tests for the second vehicle very, very soon now, which is excellent news. So that is RFA. Okay, on to our last story this week. And this story is on companies partnering to develop lunar science to construction pipeline. And both of these companies I've talked about on my channel already. I've got dedicated video on both of them. So the companies are Astroport Space Technologies and Venturi Astrolab. Astrolab is working on a LTV or lunar terrain vehicle, and they hope to win a NASA LTV award. This will be a very large rover that can carry crew, but it can also be remotely operated. So anyway, let's read this article. It says, companies partner to develop lunar science to construction pipeline. MOU or Memorandum of Understanding has been signed by Astroport Space Technologies and Venturi Astrolab. And this is for the establishment of a science to construction pipeline for lunar site preparation. For the completion of a field demonstration, they recently completed a field demonstration using a prototype of a specialized lunar excavator payload, which you can see here. It's the chassis of a Flex rover from Astrolab, but on the front here you have this excavator equipment that's provided by Astroport. And it's the first in a planned suite of automated lunar construction solutions designed to pave the way for future lunar construction projects. And we have this quote here from Sam Ximenez from Astroport, and he says, leading with a successful excavator demo proves that our technology is no longer theoretical, it's operational, unquote. So the integration of Astroport's autonomous construction tools with Astrolab's flexible logistics and exploration rover, or Flex rover for short, the excavator demo serves as a proof of concept for a family of interchangeable automated tools under development. And these tools help perform site preparation required for mission assurance on the moon. So the Flex rover will serve as the primary industrial workhorse for the suite of Astroport's automated civil engineering tools. It will enable large-scale autonomous construction operations on the moon, including site preparation and excavation, launching and landing pads. This will involve sintering surfaces for safe landings and lunar roadways. We have a quote here from Sam Ximenez from Astroport saying, turn Astrolab's Flex rover into the Swiss Army knife of lunar construction, and we must build the port before the ship arrives. And we are partnering with the US Space Force, NASA, and commercial partners with a shovel-ready construction capability to secure the lunar high ground, unquote. And a quote from the CEO of Astrolab, we are excited to provide the mobility backbone for Astroport's groundbreaking, literally, construction technology. Astrolab is dedicated to establishing a viable lunar ecosystem. So that is the article. So I covered both of these companies. So Astrolab is working on LTVs or lunar rovers, and Astroport is working on lunar infrastructure, specifically roads and landing pads for our future lunar base. And we have some renders here, and these renders are quite old. If you look at this render, and this is from a few years ago, it looks very similar to me to a Flex rover. So it looks like they had decided a long time ago they wanted a partnership with Astrolab just by looking at this render here. So you can see in the background, you can see a starship, and then you've got these 3 rovers moving regolith around. Then we have this render here, so you can see launch and landing pads, and you can see various rovers around and roads between them. And we have another render here of a starship landing on one of the constructed landing pads. And we have another one here, and this one here as well. You've got various rovers moving regolith around and generating tiles from lunar regolith, and then placing the tiles onto the landing pad to create a very secure, stable landing pad that doesn't generate plume, dust, and ejector. And we also have this video here, so let's have a quick look at this video. This is lunar lander recycling for in situ resource utilization. So you can see a mobile crane there, boom crane, and you can see this shelter, unpressurized shelter. They put in a lunar lander and then they can deconstruct it. They basically convert it into raw materials, and then they can extrude parts or components from the lunar lander. And then you've got a new component which you can use for something else. So that's one of the ideas. That is video from them. We also have this graphic here, which gives you an idea of the kind of materials they're talking about. So construction materials, bricks, rebar, fiber, geotextiles, and construction mesh and glass. You can make glass. Glass is just silicon dioxide. So there's plenty of silicon in lunar regolith, and half the lunar regolith is basically oxygen by weight. So making glass, making silicon solar panels should be quite easy on the moon once you have the technology. Various other minerals, volatiles, you've got iron, aluminium, titanium, magnesium, silicon, calcium, and trapped gases are volatiles, oxygen, helium-3, and lunar water ice. Here they're talking about the different technology readiness levels for their 3D printing and emplacement, and their geotechnical site preparation, lunar terrain testbed, and tractor tools, sieving, excavation, grading, compaction. So they're working on all the engineering. So you have to do grading, leveling, and compaction when you're making roads. Astroport is one of the companies working on that. Also, Redwire, with their Mason technology, is also working on the same set of tools, both for the moon and Mars. Lunar roads may not be that sexy, but they're absolutely vital. You need to be able to move easily between locations. The problem with the moon is there's very low traction, which makes it very difficult to move around without tipping over. You either have to go at very low speed or you're taking a risk. So the way around that is you build lunar roads, which are very flat. You grade them, you level them, you compact them, you put tiles on top of them, you sinter the ground, and now you can move at maybe 10, 15, maybe even 20 kilometers an hour. Otherwise, you're taking a risk. And also, like, you need to do this kind of site preparation for nuclear power plants, for habitats, for any kind of outpost or base. You need to level the ground. Very important that that site preparation is done, especially with Elon Musk now pivoting towards the moon and potentially building very, very large moon bases with rail guns and so on. You're going to need a lot of lunar infrastructure. So Astroport is well placed. So that is basically all the news I want to cover this week. My next video will be on the moon, and it will be on the various regions or locations in the lunar South Pole region that I think have specific use cases. Maybe there's one location that's best suited for NASA, and another for US Space Force, and another for commercial, large-scale commercial development. So I think there's a number of locations which are well suited for specific use cases. So I want to go over those regions, 4 to 5 or 5 to 6 different regions. So that will be my next video, and that will hopefully be out on Friday of this week. Anyway, thank you for watching this midweek space news, and if you haven't, please like and subscribe, and I will see you next time.